Nepal, a land of mountains and remarkable beauty. But life is hard for the thousands of Nepali people living with a disability. They face huge challenges getting around in a mountainous country, but the cultural challenges are just as great. Disability is often highly stigmatized and viewed as a source of shame. Nepali people with disabilities face a chronic lack of medical care. For over 65 years, International Nepal Fellowship has been providing life-changing medical care for some of Nepal's poorest people. But there's still a lot of work to be done. Due to the challenges of shipping medical equipment to Nepal, INF has struggled to meet the demand of their patients. One area that has been affected is their supply of wheelchairs. This has forced INF's hospitals to reuse old or broken chairs. To create a solution for this problem, INF partnered with the Collaboratory at Messiah College. They asked the Collaboratory if they could create a locally manufacturable wheelchair for Nepal. And therefore, the Nepal wheelchair team was created. Hello everyone, my name is Harrison Crosley. I'm the Student Project Manager of the Nepal wheelchair team, and welcome to our symposium presentation.
Hello, my name is Alex Vart, Senior Mechanical Engineer and member of the Nepal wheelchair team.
And today we would like to give you a brief overview of our project and how we are planning to create a locally manufacturable wheelchair for Nepal. As previously shown, our partner is International Nepal Fellowship, a Christian medical organization providing medical care to Nepal. Our project is working alongside INF's Green Pastures Hospital to create a manufacturing plan that can be used to build wheelchairs locally in Nepal. To accomplish this task, our team's goal is to design a wheelchair that can handle Nepal's terrain but can be made only from local materials. The problem that INF faces is that they are in constant need of wheelchairs. INF currently orders 100 wheelchairs for $250 a chair. Once the order is placed, the wheelchairs take anywhere from weeks to even months to arrive at INF's hospitals. Not only is this process costly, but by the time wheelchairs arrive, INF is forced to make another order to keep up with the demand of their patients. To create a solution, our team began by researching wheelchairs that have been used in third world countries. We found plenty of designs that could give inspiration for our own wheelchair. However, one thing we noticed about each of these designs is that all of their parts were manufactured in a first world country and then shipped to the third world. Whereas our design would have to be completely made in Nepal without foreign manufacturing. Therefore, our design would have to be simplistic yet comparable to other wheelchairs used in the third world. From our research, we created two preliminary designs that could be presented to INF. Our plan was to create two 3D models that INF could provide feedback on during a site team trip to Nepal. The models that we created were the Freedom 4-wheel and the triangular chair designs. Each of these designs take a simplistic approach. The Freedom 4-wheel aims to reduce the length of the manufacturing process by using only 90-degree angles for the frame. The triangular chair uses the structural integrity of triangles to create a strong and easily manufacturable design. Now that these models were created, the team set out on the long journey to Nepal to meet with INF. This past January, members of the Nepal wheelchair team and the Collaboratory traveled to Pokhara, Nepal to visit INF's Green Pastures Hospital. During this trip, we experienced the culture of Nepal while providing engineering solutions to INF. This experience was unforgettable, but it also allowed us to learn about INF and their organization. At our first meeting with INF, we presented the Freedom 4-wheel and the triangular chair designs. INF staff made it clear that the triangular chair was the most viable option for Nepal. They said it was a stable design and that it was familiar to current wheelchairs that the hospital was using. From that meeting, we decided to take their feedback and move forward with the triangular chair as the final design. Now, as I said before, one of the main challenges of this project would be to find local materials to make the wheelchair. Before the trip, we wondered if we could find the available parts, materials, and tools needed to make a wheelchair. We discovered that the materials necessary to build a wheelchair would not be hard to find. After traveling around Pokhara, Nepal, we located metal yards, hardware stores, and bike shops where we could acquire materials. Metal yards could help us find steel that we needed for a metal frame. Hardware stores could provide caster wheels, bolts, and tools. And bike shops could provide us with the hubs and wheels needed for a wheelchair. These parts and materials were purchased and brought back to the US to build a working prototype. After everything we had experienced in Nepal and all the feedback that we received from INF, we have finally created our final design.
The triangular chair is built using a simple frame consisting of two right triangles connected by lateral bars. The diagonal sides serve to create a strong, stable structure which can easily be replicated. The main wheels are attached on a camber of 3 degrees to add stability and ease of motion. The wheels will be made from repurposed bicycle tires, and the caster wheels will be obtained from local vendors. The frame has been modified to accommodate the model that was found during the site trip. Wheelie bars were added to the back at the request of our client. Caretakers press on these to raise the front end of the chair, allowing for travel up inclined surfaces. Footrests will be able to flip into an upright position to allow patients to exit the chair more easily. The seat and armrests will be welded directly to the frame, and the latter will have a barrier built in to protect the patient's body and clothes from making contact with the wheels. Our team also performed a finite element analysis on the design. Finite element analysis is a process in which SOLIDWORKS analyzes the effects of forces on a model to find areas where the model is most likely to break. When we performed this test, we found that the model was able to withstand the forces that would be applied during use. While our team had hoped to begin prototyping during this semester, events caused by COVID-19 have left us unable to do so. However, our team has found other ways to stay busy and stay on track with our goals. For SARS, we have begun working on the instruction manual that will allow INF to construct these wheelchairs in Nepal. We have also begun researching weld fixtures, which will allow INF to get the angles necessary on the wheelchair when they cut and weld the pieces together.
Overall, working on this project has been a meaningful experience on so many levels. We saw the beauty of this country and the beauty of its people. Working with INF and designing a wheelchair has an impact on all of our lives, and we hope that our efforts will have an impact on the lives of patients at International Nepal Fellowship.
From heaven for our redemption, our God alone, who died for sin that we